quantifiers, and before quantifiers we had looked at propositional and predicate logic. We looked at what are predicates and what are predicate functions, and we had looked at predicate logic. Okay, do you have any questions? We looked at things like this. If p of x is x greater than 3, what is p of minus 1? What is p of 5? Things like this. Domains of x. We looked at more complicated functions, functions which involve more than one variable. And we looked at we looked at domain of, for example, what is the domain of A, domain of B, domain of C. So we looked at the domain, and we know that domain is very important to find out the value of the quantifier. And then we looked at combining multiple predicate functions using the operators and or bidirectional XOR. So you can combine these just the way you've been combining the propositional logic things. Then we looked at quantifiers. We looked at two quantifiers, for all and for some, or there exists. And we also looked at a uniqueness quantifier, which is optional. We won't be dealing with that much in this course. So these are the two main ones, for all and for some. So any questions till now? We looked at this is more like an and, this and this and this and this, to look at every element to find out if it's true or false, and for there exists this or this or this or this to find out if it is valid or true or false. Okay, so we had stopped at slide 19. So please go through the slides and let me know if you've understood everything till slide 19. So we'll start off with slide 20 today, inshallah. I'll give you 1 or 2 minutes. Just go through. If you have any questions, you can ask. Okay, so let's begin. Bismillah ar-Rahman ar-Rahim. Let's say there is an English statement. Tomcat is cute. So I want to translate this English statement into logic. So how do I do it? I need something like this to indicate it. So I need to translate this into logic. So the first thing I'll do is I'll come up with the function. So I say px denotes x is cute. Okay, and then to translate this statement, all I need to do is top. So what does this mean based on this definition? So this means Tomcat is cute. Is that clear? Okay, so in the exam, in the midterm, we will give you an English statement and say just convert it into this. So you have to decide this. You have to decide this. You could have also said C of x. If you don't like P, you could have also said C of x. Or you could have named it cat. Okay, as long as you give this definition, it will make sense. So cat, Tomcat means x is cute, and here Tomcat is cute. Okay, let's take up another statement. Let's take up another example and say all cats are cute. How do I translate this? Again, number one, we come up with a function, predicate function. So p of x denotes x is cute. Okay, but the problem here is this word, all cats. So now how do I write this? Very good, Sultan, very good. Okay, so I do it like for all x, that is all cats, p of x. That's my answer. Okay, this is about 4-6 marks in the exam. So just converting this to this, all you have to do is define this and then give this. Okay, for all x, p of x means all cats are true, but you also need to specify what is x. That is very important, the domain. Without the domain, because x could be a tiger, x could be a dog, x could be a car. So the domain is all cats. Okay, so when I say for all x, it means for all cats. Is this clear? So I need to specify this, I need to specify this, the first and the second thing. Then the third step is clear. Without 1 and 2, 3 does not make any sense. For all p of x equal to cute. Okay, so you need to specify this. Is this clear? Okay, let me change the domain now. Let me change the domain. Now how do I write this? Okay, so this, I've changed the domain. Again, p of x is cute, but I've changed the domain to all animals. Now how do I translate the statement all cats are cute? All cats are cute. How do I translate this? For some p of x, yes, but it does not exactly tell me. It says for some x means some animals are cute. It does not tell me all cats are cute. It just tells me some animal cute. So good try for us. Good try. Anyone else? Okay, I know I have to use all because it's for all cats. So I need to use all. So I know I have to use all something. And I know I need to use this because all cats is true. But what else will I need? The thing I'll need is I'll say if x is a cat, then x is cute. Okay, if x is a cat, so I have cx, another function which says x is a cat. Okay, very good, Ali. So all cats from animals. So this statement c of x, it says if x is a cat, then x is cute, and this is true for all x. Is this statement clear? Okay, very good. Okay, so what does the statement tell us? What does the statement tell us? What does the statement tell us? It says if x is a cat, then x is cute. Is this clear? If x is a cat, then x is cute. Muhammad Ali, did you get that portion? Just the green portion. It says if x is a cat, then x is cute. If x is Tom, Tom is cute. If x is something else, Garfield, Garfield is cute. If x is Mickey, Mickey is cute. Whatever. So it is true. So when I say all, it says for all, if x is a cat, then x is cute. Okay, is that clear? Sultan and Muhammad Hamdali. Okay. Now, the reason I put it up, I just put it up because I have some experience with this. I just wrote that statement. But if you don't have experience, it'll take a lot of time to come up with such statements. You can write all x twice, but the time when you say all x, it means all x. So you don't need to write it twice or 3 times. It still means the same thing. We're talking about all x. Okay. So I'll just write it again. So all cats are cute. So the first thing I need to define is p of x means x is cute, and then I have another function c of x which says that x is a cat, and another function another says which the domain of x is all animals. And then with all of this, now I just say if x is a cat, then x is cute, and this is true for all of x. Okay. Sometimes you might be tempted to write this. Say x is a cat and x is cute. Okay, x is a cat and x is cute, and this is true for all x. Okay, but this is wrong. This is wrong. Okay, so when we are talking about all, you take this. Okay, so why? For all means, for all means and. So this will never be true because x, so for this to be true, it has to be true for all x. So when we say for all x, this internally has to be true for all x. It is not true for all x. It's not true for a lion, for example. So you'll have a false and a false, which makes the expression false. So it'll never be true. Okay, so you can look at the truth tables, you will understand. But for now, just remember this, that when you're talking about all, do not use and, use the if. Otherwise, it'll never be true. Okay, so this is something to remember. Okay, and this is only when you have, I'm sorry, the domain as animals. If you have this is slide number similar to slide number 20. Okay, we will look at slide number 20, but just look at this for now. Okay, if the domain is only cats, then all we need to do is we just need p of x. If the domain is cat, this is enough. Okay, let's look at slide number 20 now. Every student in this class has taken a course in Java. So I'll rewrite the statement. Every student in this class Java has taken a course in Java. There's a problem with my pencil, I think. Arjan, no. Why is it not writing? Every student in this class has taken a course in Java. Okay, so this is a question in the exam. So if you see this question, every student in this class has taken a course in Java, you need to give me a solution. So let's say Sultan looks at this question. He says, okay, it's a very simple question. So every student means all. So I have all of X. Abdullah Faisal, just hold on. Okay, I'll finish this and I'll get back to you. So for all X, and he's taken a course in Java. So his X is this. So X, J of X here says that X has taken a course in Java. X has taken a course in Java. Okay, Abdullah. Okay, so you have for all of X, J of X, and X has taken a course in Java, and Sultan says my domain X is students in this class. All students in this class. Okay, so he writes this for all X, J of X. So this is a complete and a correct answer. Okay, but Muhammad, he chooses this. He says, okay, this is right. But domain Muhammad Ali says, no, I want all students. So he will write it in a different way. His solution in the exam will be, okay, for all X, but yes, if X is a student, then he has taken a course in Java. So he gives me this solution. Okay, so when the teacher sees this, he says, okay, this is also correct. Why? Because they have different domains. The first one, he says the domain is just all students in this class. Sultan says that that's my domain and this is my answer. So I give him full marks. And Muhammad Ali says my domain is all students. All students is students who are not in this class. Students in Japan, students in Korea. So S of X, he defines it as X is a student in this class. Okay, Ali Habib's, thank you very much. Okay, so when Ali Habib says X is a student in this class, so this statement says if X is a student in class, which means he's not a student in Japan or Korea or anywhere, he is a student in this class, then he's taken a course in Java, and this is true for all students. Okay, we don't write it like this, just although it appears to be the same, we don't write it like this. Okay, this is not what we intend to do because this will never be true. Okay, is this clear? Okay, let's take another example. Don't worry if it's not clear. We'll take a few more examples and then slowly it will become clear. This is the first example, so maybe it's not very clear. So as we progress, it will become clearer. Okay, some students in this class, we say some student in this class has taken a course in Java. Okay, again we go back to Sultan. Sultan says my domain is only students in this class. So using the same definition, Sultan gives me this answer. Is this correct? And Muhammad Ali also says the same thing. So according to them, because their domain is that, so this is the answer. Okay, Sultan, nice. You're using 3 for that nice symbol. I would have just sat there thinking and thinking how to put that there. Okay, so this is the correct answer. But someone else might say, no, my domain is all students. So if I have all students, then I need to do a few changes. Say, yes, this is for some. Okay, I'm talking about only some students. And of course, I'm talking about X has taken a course in Java. But I say X has taken a course, X is a student in this class and X has taken a course in Java. And this is true for some students, where X is a student and X has taken a course in Java. So here, although you might be tempted to write this, if X is a student, then this is incorrect. It does not apply. Okay, for some you use the operator AND. Okay, I'll just give you a small reason why this cannot be true. For example, X has taken a course in Java, so we have something here. X has taken a course in Java. For example, the student in Philippines has taken a course in Java, so this is true. Okay, but is X a student in this class? He's not a student in this class, but this expression will evaluate to true. You understand? So this is not what we want. So we don't use this. So although it might, from the English perspective, it might appear to be true, this is not true in our case. So if you have some, just make sure you're using and for all, just make sure you're using if. Okay, so let's take another example. We will skip slide 22. Just let's skip slide 22. It just confuses you. Or we will look at slide 22. I'll rewrite it. So statement here, number 1 is all men are mortal. Socrates is a man. Okay, so we have two English statements. So we need to translate this. So how do we start off? Okay, all men are mortal. Yes, we need the quantifier all, but men mortal. So we need something to relate this. So my first job is to find out a function. So I'll call m of x, which means x is a man. I'll just write this as man. Man of x. X is a man, and mortal. I say x. X is a mortal. Okay, so we have x is a man, x is a mortal. So we have two functions that we defined. So how do we translate statement 2? 2 is very simple. 2 is very simple. Yeah. So Muhammad Ali translated the first one also. So all men are mortal. So I have all men and mortal. This is the first translation. All men are mortal. And the second translation is no. Socrates is a man. Okay. So we have Socrates is a man in the second one, and then all men are mortal. All x, no, I'm sorry. We have to say if x is a man, then x is mortal. So we have for all x, if x is a man, then x is mortal. Okay, so this is another example. Okay, is that clear? Okay, so let's move on. Okay, so slide number 23 basically says if you have something like this, it's equivalent to this. Okay. Okay, so this is equivalent to this, so we still use the same symbol of equivalence. So the expression on the left should have the same truth values as the expression on the right. Yeah, yes, Muhammad Ali, it's just not But here the purpose is to say that the expression on the left, this one, has the same truth value as the expression on the right. So this is equivalence in predicate logic, the same as propositional logic. Okay, so for example, if you just giving you some more examples about equivalences, when you say all x p of x, it is the same as and the domain of x, let's say the domain of x is 4, 6 and 9. If the domain is 4, 6, 9, so this is true for 4 and it is true for 6 and it is true for 9. Okay, so this and this mean the same thing. Okay, so they are equivalent. For some, this is equivalent to p of 4 or p of 6 or p of 9. Okay, so this on the right hand side and the thing on the left hand side are equivalent. Okay, is that clear? That is one. The second is, for all you use conjunction or the and operator, and for some you use the disjunction or the or operator. Okay, so let's move on. Negating quantifiers. Negating is very simple. It's very simple. Okay, so if I give you this, okay, how do you negate this? Okay, yeah, just change the for all to for some. So you just change it to for, from that to this, but move the thing inside. Move the thing inside. That's all. And you have something like this. Move it inside. Change it and move it inside. That's all. And this is that famous De Morgan's law that you had taken up long back. Okay, is that clear? Okay, now we'll do some experiment with this. So we had every student in the class has taken a course in Java. So every student in your class has taken a course in Java. So you will be given a statement like this and said in English, every student in your class has taken a course in Java, and you will be asked to find its, you will be asked to negate it. Yeah, when you will be asked to negate it, just do this, put a symbol here, and then this is your negation. Okay, that's all. So you say, don't try to translate this into English. It won't make sense. But if you do try, it will say it is. You can say it is not the case that every student in your class has taken a course in Java, or you can say there exists at least one X who has not taken a course in Java. So this is the negation of that statement. Okay, on slide 26, it says there is a student in this class who has taken a course in Java. So yeah, Ali, you can play around with English, but as we progress, you will see that English is not so easy. So we'll be moving, and it's easy to work with logic. This is much easier for us to work with, and as we progress, we will realize how confusing it will get. Okay, now I want you to jump to slide 27 and solve it, or don't look at the slides. Don't look at the slides, please. Okay, negate this expression. Negate this expression. How do you negate it? So you negate it like this. You put a negative here. Negate this expression. So you get this. Then the next thing, yeah, you move it inside. So this changes, and you get x square greater than x. Okay, very good. But can this also be Simplified? Yeah, tell me what it is. Muhammad Ali? Very good, very good. Qasim, very good, very good. Okay, so it will be this, and then x square less than or equal to. Less than or equal to. Be very careful. The opposite of this is this. Okay, very good. Is this clear? Let's take another example. Okay, very good. This is very simple. These are full mark questions. Nice, Ali. Very good. Nice message. Okay, so let's take another one. You'll be seeing this in the question. These are full marks. These are full marks questions. So when you see this, negate this expression. Negate this expression. Negate this expression. Very good. Okay, so for negating, I just put this in the front and then flip that, and this goes inside. So we have x square equal to x. Okay, so Muhammad Ali has already simplified it. Very good. So can I simplify this further? Ali Habib also has done it. So I get for all x, x square not equal to x. Okay, not equal to x. Very good, Qasim. Okay, Qasim has used the symbol from his programming, so not equal to x. Both are okay. Okay, you can use the mathematical symbol like Muhammad Ali has done, or you can use the symbol that Ali Habib and Qasim have used. So both are okay. Okay, let me give you a very, very, very complicated one. A very complicated one. I give you a big expression like this and say negate it. Negate this expression. So how do you do it? Okay, expression like this guaranteed in the exam. Similar to this. So how do you do this? Very good. So I change the first symbol. I flip the first symbol. Okay, and then I get this whole thing. Then again I move that, I flip the other symbol. Okay, then I get that not. Then again I flip the third symbol, fourth symbol. So I get this, and then not Q, X, Y, Z. That's all. Yeah, that's all. Look at Ali Habib. He's using so many symbols there. Okay, very good. So this is almost a 4 marks question. Free 4 marks, right? It looks so scary and it looks all that, but it's so simple. Yes, Abdullah. It's some of them are free marks. It just looks complicated. People who have not looked at the slides and they look at this, they don't know what's going on, and they drop the course. It looks so scary, but if you saw the examples in class, this is free marks. Free marks. Okay, look at slide 28. I think it's self-explanatory. I will not explain it. Slide 28, De Morgan's law. The laws that you just used. There's a name now. So that's the De Morgan's law. Is that clear? Slide 28. Okay, very good. Okay. Now let's go to slide 29. Don't look at the slide. There are two statements. Some student in this class has visited Mexico. Okay, we need to translate this from English to logic. Some student in this class has visited Mexico. So how will we go about doing this? Number one, we need, for some means we need this symbol. We need this symbol. And if we are using some, we need the and symbol, just to make sure. Then how do we go about doing it? Some student in this class. So we have to make sure that that person, let's say the domain X is all people in the world. Okay, so I have to make sure that he is in this class. So X is a student in this class and X has visited Mexico. That's all. Okay, Muhammad Ali has also done it. Is this clear? Some student in this class visited Mexico. Okay, so this comes with practice. So now if I give you a third example, you'll do it in probably 30 seconds. It just needs practice. Yeah. Um, Muhammad Ali, very good. So Muhammad Ali says, is this okay? Is this okay? So uh, actually, what is S for you? What is S of X? What is S of X? Is, do you mean X is a student in this class, or do you mean this? Maybe you mean this, Muhammad Ali. Because if you say X is a student, it's not some students in this class has visited Mexico. You're just saying there are some students in this class. That's all. Where is the Mexico part? Okay, the Mexico part is also important. But if I just say this, if I say this is okay. Where X is the domain says X students in this class. Domain of X is only students in this class. Now it is okay. Only so much is okay. So it says there is some there is some X where X has visited Mexico. Who are X? Students in this class. So this quest, the first one is also correct. The second one is also correct, depending on the domain. Okay, Muhammad Ali. If Sultan, if X is all people, we use the solution number one. The answer is solution number one. If the domain is all students in this class, the answer is number two. Okay, if you look, we have said all people, the domain, the first case. Is that clear, Sultan? It depends. X can be any domain. So for example, in the previous class, we had said X is integers. We can say X is integers. We can say X is positive integers. We can say X is positive integers greater than 4. Okay, so we have to define the domain. So here we can say X is a student in my class, X is a student in FCIT, X could be a student. So we are X can be a person. So we can keep the domain open. So here we have said X is all people. Okay, because X is all people, we have to first tell that that person is a student. So which is why we're using this. We have to constrain over here, because why are we using students? It's a very good question, people, because when you're talking about a large software, because this course is not limited to only this class. When we are talking about software, X could be a student, X could be staff, X could be a visitor to the university, X could be a parent, X could be a visitor to the website. So that's why we need to keep X as all people when you're talking about a big software. Do you understand, Sultan? So we keep our options open. Okay, so it's a good question, but we have to think in a broad way. We cannot say the user is only a student in this class. You're talking about a small software, or we're looking at a problem in a very small, short-sighted way, in a constrained way. So if you're looking at it in a broad way, we say X is any student, any person. Okay, yes, Muhammad Ali. M means X has visited Mexico, and uh, S of X means X is a student. Okay, is that clear? We will take another example. We'll take another example so that it is clear. We'll say all squares of a number are positive. So how do I translate this? All squares of an integer, all squares of an integer are, yeah, are positive. So how will I say this? I need to translate this into logic. All squares of a number are positive. Okay, so I need for all. Okay, so I can just say this: x square greater than 0. Yes, so there's a mistake you're making, Muhammad Ali. Check, or I can say p of x. Okay, so I can say this. This is a solution. I'm saying for all x, p of x is true, which where p of x is defined as x square greater than 0. Okay, so this is a solution. This is a solution, but here x are integers. We are talking about x, but x could also be a number. It could be a number. So how do I specify it is? So here the domain of x is minus 1, 0, 2, 4. So it's minus 8. So x could be a positive integer, it could be a negative integer. So that's the domain of x. But what if the domain of x? What if the domain of x is any number? So this will not work because we are not talking about all numbers. We are talking this statement, English statement talks about only integers. So I have to first say it's an integer. So I use if x is an integer, like Muhammad Ali has put it, if x is an integer, then the square is positive. And this is true for all numbers. It is true for all numbers. All numbers means if x is a integer, if that number is an integer, then that number, square of that number is positive. Okay, Muhammad Ali, I told you when you're talking about all, use the implication, not the and. Yeah, okay. Okay, is that clear? Okay, inshallah, in the next class, we'll be looking at some more examples. Muhammad Ali, very good. So we will look at more examples, and I'm not sure how many of you are sleeping today. I didn't ask you, so let me check. Just ask. Before we stop for today, just make sure. So I have Muhammad Ibrahim saying yes, he's still sleeping, and Muhammad Ali, he's still sleeping. Okay, no problem. At least I want replies, I want responses. Okay. So as long as you're responding, it is okay. Wake up, respond, and go to sleep. So we have 10 people who are really sleeping. Faisal, no problem. Yes, no is not important. Just the response is important. Just to make sure that you're listening. Rami, Sadan, Saeed, Abdullah Khalid, Abdullah, Abdullah Khalid, Mu'taz, Hisham. Where are you? Rami, Sadan, Saeed, Abdullah Khalid, Mu'taz, Hisham. Yeah, they're sleeping. Okay, so we will stop at this for today. It's very, very important that you solve the problems in class. If you want to get a good grade, it's very easy to get an A plus in this. A is simple. Getting an A is simple. Maybe some of the topics are a bit tricky, but otherwise A is not very difficult. Please follow what I'm doing on the whiteboard. There is a reason I don't use slides, because the slides are a bit complicated, if you and scary. So that's why I go little by little, and I get back to the slides later on. So please follow what's going on in class, or if you're really sleepy, watch the video later on, and make sure you understand what happened in class. Okay, that's all for today. Enjoy the weekend. Next class might be handled by someone else. I'll be traveling to India. Hopefully, I will be able to take, but if I'm not, there'll be another instructor, Dr. Vijay or someone who'll be handling the class. So enjoy your weekend. That's all for today. Assalamu alaikum wa rahmatullahi wa barakatuh. Yeah, inshallah, Ali Habib, I'll be coming back. Inshallah. I don't know when the flights will open, but just make sure, inshallah, the flights, I get a good flight and an early flight back. We don't know.